A product manager hands a development team a simple instruction: create a task feature. On the surface, it seems clear. The team assumes they know exactly what to build. The developer writes the code and gets the basic action working, but they focus entirely on the happy path. They miss the variations, ignoring what happens when a required field is left empty, or what the user sees while the page is loading. Quality assurance testers verify that a task can be created and pass the feature along, yet hidden gaps remain. For instance, any user can delete the task because no one explicitly mandated a check for user permissions. During the final client review, the product breaks down. The client points out that their AI-generated test cases aren't saving properly. The developers are caught off guard because that specific expectation was never documented. When requirements lack explicit acceptance criteria, the development process relies on assumptions. This leads to overbuilt features, weak testing, and disagreement over what the software was actually supposed to do. A requirement is not ready for implementation until the exact conditions for its completion are defined and testable. This document uses the given, when, then format. Given a developer is on the task page, when they click Save, then the task is visible. For simpler tasks, a checklist format provides a binary list to verify specific states. Regardless of which framework the team chooses, the function is the same. They provide a standard baseline for behavior, removing personal interpretation from the review process. To secure a feature's scope, teams use specific parameters to fence in the project and account for potential failures. This document defines those parameters, setting rules for error handling and UI states like loading screens. Panning down, sections for data and AI behavior dictate how the system handles user data and AI-generated suggestions. By mapping out all potential UI states and dictating how data is handled, developers know the exact variables they need to solve for before they start. It is equally important to set boundaries for what the feature will not do. The criteria should list out-of-scope items, like notifications, to keep the team focused on the current slice. Layering these 8 pillars forces the team to resolve logical conflicts and address blind spots before writing the first line of code. Once established, these criteria serve as the primary operational blueprint for the entire build. These criteria are especially effective when working with AI coding assistants. By providing an agent with a prompt like this, instructing it to only implement features on the list, teams can prevent agent drift and irrelevant code. Quality assurance teams use these same instructions to generate a testing matrix, ensuring they verify the exact behaviors the system was designed to execute. Clear criteria keep developers, AI tools, and testers aligned on the same objectives throughout the development lifecycle. This checklist outlines a pre-implementation routine. The team confirms criteria are written, testable, and cover necessary edge cases. Before calling a task finished, they perform a final check, verifying every criterion is met and test evidence is documented. This procedural approach replaces the chaotic subjectivity of vague requirements. When every parameter is documented, there is no room for stakeholder disagreement. Acceptance criteria define done through verifiable evidence. When every item on the checklist is confirmed, the product meets the agreed-upon scope, protecting both the timeline and the final product.